now we'll be looking at some of the rules of integration. So we might be required to solve some questions in which applying a general formula for integration might not just work straightforward. So what do? We try to apply some of the rules to see if there's a way we can manipulate the question to a form that can be easily simplified. So the first rule that we'll talk about is integration by substitution, and this is also referred to as the reverse chain rule. If you recall our discussion on chain rule when we were talking about differentiation, what we did was that we replaced a term or an expression by u, and we tried to simplify and manipulate the function to be able to differentiate it. So the same idea applies here. So what we do is that we try to substitute some particular term in our function so that we can convert it to a form that can be readily evaluated with our standard integrals. So now we're going to talk about some examples so you can see how to apply this specific rule. So in this first example, we are told to integrate this expression over here with respect to x. So how do we go about this? Definitely we cannot do this directly because we have 2x plus 3 raised power 5 and we don't have any formula that tells us how to differentiate something of this form. So one thing we can do is we can try to expand this expression over here by multiplying 2x plus 3 by itself 5 times, but that would be a very tedious and tiring process. Fortunately for us, we don't have to go through this means. So what we can try to do is to try to substitute. So what we want to do is that I want to write out everything that is here in terms of u, in which u can be directly evaluated based on the formula for integration that we already know. So if we replace everything that is in between here by u, we say let u be equals to 2x plus 3. So now we have gotten or have equated what is here to u. But now we want to write the x also in terms of u. And how do we do that? We differentiate this function. So we have du over dx. When you differentiate this, what do you get? The differential of 2x or derivative of 2x gives me 2. And the derivative of 3 is 0 since 3 is a constant. So if I cross multiply, I have 2 dx to be equals to du. So if I divide both sides by 2, I can say that my dx is equals to what? Du over 2. So I can replace x squared plus 3 by u and I can replace the x by du over 2. So this can be written as the integral of u raised to power 5 times du. Then I'll have this as over 2. Du over 2 over here. So now I have u raised to power 5, which is synonymous to having x raised to power n. And we know that based on the general formula, if I differentiate this with respect to x, comes x raised to power n plus 1 over n plus 1. So rather than having x now, we are just having u. So the same rule applies. So to integrate this, it becomes what? U raised to power 5 plus 1 over, I already have 2 in the denominator, 2 into bracket what? Then I have 5 plus 1. Then plus my constant of integration plus c. So what does it become? It becomes u raised to power 6 over 2. 5 plus 1 is 6. 6 times 2 is 12 over 12 plus my constant of integration. Now I can replace back my value of u as 2x plus 3. So this becomes 2x plus 3 to the power of 6 over 12 plus c. So this is how we go about using substitution to solve integration questions. So let's look at another example. In this example, we are told to evaluate 3 dx over 4x minus 1 to the power of 3. So what do we want to do? We want to first try to write this to a form that is recognizable. So based on our law of indices, I can also write this as the integral of 3 into bracket 4x minus 1 raised power of minus 3. If you remember, when you have minus 3, same thing as having 1 over this, then with respect to x. So 3 is a constant. I can easily bring that out. So I have 3, then I have integral of 4x minus 1 all raised to the power of minus 3 times dx. So I can now apply my substitution. So again, I'll say let u be equals to what is in the bracket. So u becomes what? 4x minus 1. So now I try to find the x in terms of u. So my du over the x will be equals to what? 4, since this becomes 0. So I can write that my dx will equals to what? Du over 4. So now I can write this again in terms of u, and that is the same thing as writing 3 times the integral of, I've already said 4x minus 1 should be u. So I have u raised power minus 3. Then I have what? My dx is now du over 4 times du over 4. Same thing with this 4, I can bring it out. So you see the same thing as having 3 over 4 times the integral of u raised power minus 3 with respect to u. So I can easily simplify this. So this becomes what? This becomes 3 over 4. And my integral of u raised power minus 3 becomes u raised power minus 3 plus 1 over minus 3 plus 1. And that is what you have over here. Then plus my constant of integration. So what does that become? I have 3u to the power of minus 2 over 4 times, this becomes minus 2, then plus c, and that becomes what? 3 over 4 times 2 gives me minus 8, and this is the same thing as having u squared underneath, because u raised power minus 2 is the same thing as the reciprocal of u squared. So plus my constant. So if I replace that by value of u, which I substitute before x plus 1, I now get that to be equals to what? To be equals to 3 minus 3 over 8 into bracket 4x minus 1 squared, then plus my constant of integration. So let's check out another example also. And here we are told to integrate the following functions with respect to x. So in the first one, we are told to integrate cos 7x with respect to x. So we have to find the integral of cos 7x with respect to x. So the same thing, normally I cannot solve this directly because I don't know what the integral of cos 7x is, but I know what the integral of cos x alone is. So what do I have to do? I have to replace what is here by just a single variable. So I say let u be equals to 7x. So I know that my du over the x will be equals to 7, and my dx will be equals to what? Du over 7. So when I replace the value of u and dx here, so I get that this is the same thing as the integral of what? Of cos u times du over 7. Now I know that when I integrate cos u now, I get what? Sin u. So this becomes what? Sin u over 7 plus my constant of integration. And my u value, we know that is 7x. So which is same thing as saying sin 7x over 7 plus my constant of integration. So what is a short way of looking at this? So I want you to look at this really short. And so what we have just done here, or what the substitution is all about, so to differentiate by substitution, what we did basically is that we try to differentiate this as a singular function. And when we differentiated this, what do we get? We get what? Sin 7x. So that becomes sin 7x. Now we take this variable that is here and we differentiate this to get what? Differential of 7x gives us 7. Then we divide it by that over 7. Then we have plus our constant of integration. So I'm going to apply that logic to what we have over here. So what we have here is just, I can bring out my 6. So I have like 6 times the integral of sine of half x. So applying that, when I integrate sine x, I get what? Minus cos x. So this will just be equal to 6 into bracket what? Into bracket minus cos half x. So now I will now divide it by the differential of what is here. So when I differentiate half x, what do I get? I get half. So over half plus my constant. When I bring this half up, it becomes 2. And 2 times 6 gives me 12 times minus. So that gives me minus 12 cos half x plus my constant. So you can see you really don't need to work through all this long motion of substitution, but before you get to this level you have to have practiced a lot so you can understand what is really going on. So what I want you to do now is to try to solve this question using a normal substitution and see if you arrive at the same answer. And if you arrive at the same answer, then you know that you have truly mastered this. So what you have to do now is to try to also look at your textbook and try to see if you can see some more examples. So now let's move on to a special case of algebraic substitution. So if we have two terms under the integral sign and the differentiation of one of the terms is equal to the second terms, we can also use algebraic substitution. The following example illustrates this point. So in this example now, we are told to integrate this function over here. Now when you look at this function looks like really tedious. But what can we do? Let's look at it critically. What will happen if we differentiate what is underneath this square root? So if I differentiate 1 over x squared, I'm going to get 2x. And as you can see, x this term will be, and what do I have outside there? I have x. So this method can definitely work. So what do? I equate u to what is inside the square root. So I have u to be equals to 1 plus x squared. So now what I want to do now is to try to write x in terms of u. So I try to differentiate this. So I have what? My du over dx to be equals to what? This becomes what? And this becomes just what? 2x. So if I make x the square root of formula, I can divide both sides by 2. So my x will be equals to what? My x is same as having du over 2 dx. So I can substitute my x as du over 2 dx and my 1 plus x squared as u. So this function can also be written as the integral of du over 2 dx times the square root of u times the x. So dx cancels dx. I can bring out my half outside. So this same as having half of the integral of the square root of u times du, which is like having half integral of square root of u is same as u raised by half times du. Now as you can see, I can easily integrate this with the use of my formula. So this becomes what? Half into bracket. This becomes u raised by half plus 1 over half plus 1, and that then plus my constant of integration, and that becomes what? That becomes half times u raised by 3 over 2 over 3 over 2, in which 2 cancels 2, then plus my constant. So I'm left with what? U raised by 3 over 2, everything all over 3, then plus my constant. Now my u is what? 1 plus x squared. So I can substitute this back. So I have what? 1 plus x squared all over 3 plus my constant. So this is what we get when we integrate this function. Now let's look at one more example. So in this example now we are told to integrate x squared cos x cubed dx. So how do we go about it? So if you look at this critically, when I look at this term underneath x cubed, when I differentiate x cubed, what do I get? I get 3x squared. And what do I have here? I have x squared. So that means this rule can apply. So I say let u be equals to what? X cubed. So now I try to find out the value of x squared so I can write it out in terms of u also. So my du over dx is equals to what? 3x squared. So if I make x squared the square root of formula and I divide both sides by 3, I have my x squared to be equals to what? Du over 3 dx. So I can substitute the value of u x cubed as u and the value of x squared as du over 3 dx. So this can also be written as the integral of du over 3 dx then times cos u times dx. Now the x cancels the x, I can bring out my 1 over 3 out. So the same thing as having 1 over 3 times the integral of cos u du. Now that becomes 1 over 3, and when I integrate cos u, what did I get? I get sin u times sin u, then plus my constant of integration. So that becomes what? Sin u over 3 plus c, and I know that my u is what? X cube. So this becomes sin x cube over 3 plus my constant of integration. So this pretty much sums up how to use substitution method. So what you should do now is to try to go through your textbook and try to look for more examples, because the only way you can perfect your skills is by practice. So you need to practice more and more until you master how to go about solving integration by substitution. So now let's talk about the final rule that we'll be looking at, and that is called integration by parts. So this is derived from the product rule of differentiation, and it is commonly used when we have to integrate the product of two functions. So it is generally expressed that the integral of u dv, this is the formula, is equals to u times v minus the integral of v times du. So how do we go about this? How do we apply the formula? So we said that it is usually done when we have what? Two functions together. For instance, we can apply it. Let's say we are told to integrate, let's say, x times sine x. So now we have two terms here. We have x, the x term, and the sine x term. So we have the product of two terms. So we can apply the sine rule. So based on the sine rule, we apply one of the functions to be equals to u in this case, and we apply the other function to be equals to what? Dv. So we then find the value of du by differentiating u. So when we differentiate u now, which is x, we get the value of du, and we find the value of v by integrating dv. So when we integrate dv now, we get the integral, we get v when we integrate dv. So what do we now do? So that means by now we should have gotten u dv, du and v. So we can now substitute all these terms into the formula here. Multiply u times v minus what? Minus the integral of v again times du. So that is how we apply the formula for integration by parts. So let's see how this really plays out with the following examples. So in the first example, we are told to integrate x sine x dx. So if you look at this, obviously integration by substitution will not work here, because when I differentiate x, I do not get x, I get 1, which does not work certainly. So what do? I try to integrate by using the formula by parts, since I have the product of two functions. So now what is the formula for integration by parts? So that the integral of u dv is equals to uv. As a side note, you have to memorize this formula, minus the integral of v times du. So we assign our terms. So we say let u be equals to what? X. So when I differentiate that, du become, when I differentiate x, what do I get? I get just 1. Pretty straightforward. Now the second term, I assign a value of dv. So I say let dv now be equals to sine x. So now when I integrate dv, what do I get? I get v, and integral of sine x gives me what? Gives me minus cos x, as you should know by now. So now I've gotten the value of u, du, dv and v. I can apply it to my formula. So my formula says I should multiply u and v. The value of u is x. The value of v is minus cos x. Then minus the integral of v. The value of my v is minus cos x. And the value of my du is 1. So what does this turn out to be? So this turns out to be what? Minus x cos x. Then minus times minus, if I bring this out, becomes plus the integral of and left is just cos x over here. And now when I integrate cos x, what do I get? I get minus sin x. So this becomes minus x cos x. Rather, when I integrate cos x, I just get sin x. So this becomes the integral of cos x is what? Sin x, and I include my constant of integration. So you see, this is a very pretty simple and straightforward method. So to recap, you have to first memorize the formula. Then you need to assign one of the terms as u. Usually the value that is in terms of only x. Why it's advisable to assign the trigonometric term to value of dv. So which we have done here. Then we differentiate u to get the value of du, and we integrate dv to get the value of v, and we substitute it into the formula and we simplify. So now let's try to look at another example. So in this example, we are told to integrate x squared cos x dx. So how do we go about this? This is also pretty straightforward, and we use a formula for the integration by parts. So the integration by part tells us that what the integral of u dv is equals to uv minus the integral of v times du. So I assign this first term to be u and this second term to be dv. Then we start solving. So u is equals to x squared. So du, which is the differential or derivative of x squared, when I differentiate x squared, what do I get? I get 2x. So now dv is equals to cos x. So my v now will just be the integral of dv. Now when I integrate cos x, what do I get? I get sin x. So I can substitute that into the formula. So that becomes what? My u is x squared. My v is sin x. Then minus my integral. My v is what? Sin x. Yeah, sin x. And my u is what? My du rather is what? 2x. So what does that become? So that becomes x squared sin x minus, I can bring out this 2 over here. So I have 2, then I have left with the integral of, I have x times sin x. So now you see that under here now we have the integral of x sin x, which is the product of two terms again. So I need to solve this again using the integration by parts. So now you have to simplify integral of x sin x again by using integration by parts before you substitute it and try to simplify further. But luckily for us, our previous example was just the integral of sin x of x sin x, and we got from our previous example that the integral of x sin x, we got that with respect to x to be equals to what? Minus x cos x plus sin x. So luckily for us, we don't have to go through the stress of trying to solve this again. So we substitute this value into the integral of x sin x. So now our integral of x squared cos x dx equals to what? X squared sin x, then minus 2 into bracket minus x cos x plus sin x. Then as usual, I had my constant of integration. So that becomes x squared sin x. When I expand, minus times minus give me plus. So I have plus 2 times x gives me 2x plus 2x cos x minus 2 times sin x gives me minus 2 sin x, then plus my constant of integration. So as you can see, to recap, what we did was like what we did previously. We assigned the first term as u and the second term as dv. So we differentiated u to get the value of du, and we integrated dv to get the value of v as sin x. So we substitute the value of u, du, v and dv into this formula over here. And when we did that, in this second term, we are left with the integral of x sin x, which we are also to simplify using integration by parts. But based on the previous example we solved, we've done this before and we got that to be equal to this. So we substituted this back to what was here. So we have this minus 2 into bracket the integral of x sin x, which is minus x cos x plus sin x, then plus our constant of integration. After further simplifying it, we got this last line. So this pretty much sums up our discussion on the rules of integration. And again, it is worth emphasizing that the way to master these skills is by practicing. So I would suggest that you go to your textbook and try to practice questions that have to do with integration by parts and questions that have to do with integration by substitution. So that will be all for now.